Hi everybody, welcome back. Today we're going to be working out of our lab manual. So if you have your lab manual, I suggest you take it out and open up to page 113, please. Page 113 has the second part to the homework that was assigned to you. They are Hardy-Weinberg problems, again. And I'm going to go over how to do these problems. They start kind of at the top middle part of the page. We're not going to worry about the top of the page here. This has to do with the lab that we didn't get a chance to do, but we can still work on some practice Hardy-Weinberg questions together in order for us to feel more comfortable working on these problems. If you already know how to do these questions and you just want to jump ahead to the end of this video presentation to look at the answers and pause it, feel free to do that. If you want a step-by-step on how to do them, this is what I'm here for. This is what we're doing. So let's start with the first question. It says dark eyes are dominant to light eyes. That means light eyes is recessive. We have a population of 1,000 individuals, and 360 of them show the recessive phenotype. This is important because if we're starting with the recessive information, remember we always want to have off to the side a few things to remember. First, we have to find what Q squared is. Then we have to find what Q is. Then we have to solve for P. And then we can answer the rest of the question. Now, this question wants us to know how many individuals out of 1,000 are going to be homozygous dominant and heterozygous. So what they're asking is what is P squared and what is 2PQ. And so that is what we do after we've done steps 1, 2, 3, and then we can do step 4, which is to solve for P squared or 2PQ. Again, we're going to use our equations to help us do this. The first is the allele equation, P plus Q equals 1. And the second equation we need is P squared plus 2PQ plus Q squared equals 1. That 1 represents 100% of the population. The P represents the dominant. The Q represents the recessive allele. These are the genotypes. Big A, big A, big A, little a, little a, little a. Okay, let's tackle the question. So we're going to start with Q squared, and in order for us to do that, we're going to take 360 individuals and divide it by 1,000. This should be 0.36, and that's Q squared. Now I want to solve for Q. Well, Q is going to be equal to the square root of Q squared, and so I have to take the square root of 0.36. That should be 0.6. That should be Q. I can take my Q and I can plug that into this equation here, P plus Q equals 1. This represents my recessive allele. What this means is 60% of our population has a recessive allele in their genotype. In other words, 60% of our population is either heterozygous or completely recessive. P plus Q equals 1. P equals 1 minus Q. P equals 1 minus 0.6. That means P equals 0.4. Okay? Now I want to take this number and I want to square it because that's going to give me my homozygous dominant population. So 0.4 times 0.4 should be 0.16. Over here, 2PQ is 2 times P, which is 0.4, times Q, which is 0.6. that should be equal to 0.48. This is not the answer because this isn't what they asked us to do. They asked us to find the number of individuals. And so in order to do that, I have to take my 16% and multiply it by 1,000. And so what I do here is I take 16% of 1,000. That's 1,000 times 0.16. And so the answer for this is 160 individuals. That's going to be my number of individuals. So off to the side here, I'm going to say that my individuals that are p squared is going to be 160 individuals. Over here, I'm going to take my 0.48 and multiply it by 1,000. That's going to be my 2pq. So my 2pq is going to be 480. Now the way to check yourself is add 480 plus 160 plus 360, which is what they gave us. And so if we take those three values and we add 480 plus 160 plus 360, it should still equal 1,000. Oh my gosh, there it is, 1,000. Let's move on to question number 2. Question number 2 says the ability to roll your tongue is dominant. And we have a population of 500 individuals. 75% of them show the dominant phenotype. Well, that means 25% of the population shows the recessive phenotype. That is our q squared. And so I know that if 75% are dominant, that tells me 25% is q squared, or recessive. Again, they want to know the number of individuals. Again, for the homozygous dominant and heterozygous traits, they want to know individuals out of 500. So we're looking for 500 individuals total in our population. So if q squared is equal to 0.25, and the way we solve that is that's 25%. That means q is the square root of 0.25. That means q is 0.5. Now solving for p is easy because p plus q equals 1. P equals 1 minus q. P equals 0.5. Again, this doesn't answer anything because we still want to figure out homozygous dominant and heterozygous for this trait. Well, homozygous dominant is going to be p squared. So let's start with p squared. P squared is 0.5 times 0.5. That's p times p. Well, that's 0.25. Heterozygous is 2pq. Well, that's 2 times 0.5 times 0.5. That's 0.50. So 25% of the population is dominant, 50% of the population is heterozygous, 25% of the population is recessive. We're pretty much in perfect Hardy-Weinberg equilibrium here. So now we have to figure out what is 25% of 500. So to do that, we take 0.25 times 500, and that equals 125. So my answer here is 125 individuals for my p squared. I now want to take 50%, 0.5, of my 500 total, and that is 250. All right, question 3. Question 3 is asking about widow's peak. Having a widow's peak, which is hair on your forehead that comes to a point on your hairline. something I don't know anything about, is dominant to lacking a widow's peak. And we have a population, again, of 1,000 individuals, and 510 of them are dominant. How many individuals would we expect of each of the possible 3 genotypes? So they want to know what is Q squared, what is P squared, and what is 2PQ. They want to know the 3 possible genotypes for this trait. Well, the way we start with this is we have to solve for the recessive first. They're giving us the dominant, and we can't do anything with this. We have to start with the recessive. So the way we do this is we take our total number of individuals and we subtract the dominant individuals, and we get the recessive individuals in the population. Well, 490 individuals out of 1,000 is going to be my Q squared, and that is 0.49. So 490 individuals are going to be recessive. To solve for P squared, I now have to solve for Q and then P. Remember, we have to do this in order. Well, Q is equal to the square root of 0.49, so that's going to be 0.7. That means P is going to be 1 minus 0.7. So P is going to be 1 minus 0.7. That is 0.3. Now I can take this number, 0.3, and square it. That's going to be my P squared. That's going to be 0.09. Be careful. You're taking 0.3 times 0.3. It's not 0.9. 0.3 times 3 is 0.09. That's 9%. So if I take 9% of my 1,000 individuals, I'm only going to have 90 individuals be completely dominant. Finally, I'm going to solve for 2PQ. Well, that's 2 times 0.7, well, 0.3, times 0.7. That's going to be 0.42. And so that means 42% of my population is going to be heterozygous. So I take 0.42 times 1,000, that's 420. Now to check ourselves, let's add up all of these values. 420 plus 90 plus 490 should equal 1,000, and it does. That's fabulous. Okay, let's do question 4 together. 16% of the population is Rh negative. This is a blood type. Rh negative is recessive to Rh positive. We have a population of 2,000 individuals, and they want to know how many individuals, how many students, are each of the 3 possible genotypes. So again, they want Q squared, they want P squared, and they want 2PQ. So 16% of the population out of 2,000. That's going to give us Q squared. So all we need to do is type into our calculator 0.16, that's 16%, times 2,000, that equals 320 individuals. That one was easy. Now, let's take our Q squared of 0.16, which they're giving us here, and let's take the square root to figure out Q. If you're noticing, every single one of these questions is solved the same way. Q is 0.4. That means P is going to be 0.6 because P plus Q equals 1. And if Q is 0.6, then P has to be, Q is 0.4, then P has to be 0.6. So now we know what P is. Let's figure out what P squared is. P squared is 0.6 times 0.6. P squared is 0.36. Well, 36% of 2,000 is 0.36 times 2,000. Remember, they want how many actual people, how many individuals. So let's figure out what 0.36 out of 2,000 is. It's 720. That's a lot of people. Finally, let's do 2PQ. Well, that's 2 times 0.6 times 0.4. That should be 0.48. Well, let's see what 48% of 2,000 is. 0.48 times 2,000 gives us 960 individuals. The way we check this is we add 960 plus 720 plus 320, and it's 2,000. It's giving us 100% of the population. Remember, P squared plus 2PQ plus Q squared should equal 100% of the population. That's 2,000. It matches. We did the question right. Okay, last question is saying that 4% of Nigerian newborn babies have sickle cell anemia. That's a recessive condition. Out of a random population of 1,000, how many would you expect for each of the 3 possible genotypes again? So again, they're asking us to do Q squared, P squared, and 2PQ. Let's start with our 4%. This number is our Q squared. So what is 4%? Well, that's 0.04. So I need 0.04 of 1,000. And so to do that, I'm going to take 0.04 times 1,000, and I get 40. 40 individuals are recessive. They have sickle cell anemia. That's 4% of 1,000. Now let's solve for Q, because in order to solve for P, we have to solve for Q. Q is the square root of 0.04. That should be 0.2. Check your calculators, make sure it's true. If I take the square root, I've got to turn this. I have to take the square root of 0.04 and close my parentheses. It's 0.2. Fabulous. It's a little blurry there. So that means P equals 0.8. Again, remember, P plus Q equals 1. If we know that Q is 0.2, that means P has to be 0.8. Now, I'm going to take my 0.8 and multiply it by itself to solve for P squared. That should be 0.64. 64% of the population is homozygous dominant. So I'm going to take 64% of 1,000. So I go 64% times 1,000, and I get 640 individuals. Finally, I'm going to do 2 times P times Q to figure out my heterozygotes, my big A, little a's. 2 times 0.8 times 0.2. So this should be 0.32. Well, 32% of 1,000 should be 320. Yes. Again, let's check ourselves before we wreck our... Oh, Craig Brown is calling me. Okay, so anyway, everything is fine with Mr. Brown, and then Mr. Reza called. So we've been communicating. Everything is good. Let's just finish this up. We have 320 heterozygotes. I'm going to add to that 640 heterozygotes, and then 40, or that's homozygous dominant, and then 40 homozygous recessives. It should equal 1,000, and it does. So that should do it for all of this Hardy-Weinberg. I will direct you to look at your review. If you want to do some more Hardy-Weinberg questions on your own, there are answers in the back of the review book. Feel free to work on that. And again, any questions, contact me, Remind, Teams, email, whatever. I'm available to talk. And have a good day.